Howdy tubers, welcome back to the Zach Life. So this video and the next 3 or 4 which I'm fixing to explain are part of the playlist and the series Oilfield 101, geared towards the poor boy oilfield guy like me and pumpers, and if you want to buy some production or whatever. The next video, this video and the next couple is going to be, this one's going to be about pumping units, what the sizes mean, how to look at one, see if it's any good, things you need to look for, the different kinds. The next video is going to be, we're going to rebuild one. I may make the rebuild into 2, I don't know exactly. And then the last video, the 3rd or 4th, is going to be taking this thing out and setting it on the well and hooking up, basically. Anyway, I'd like to clarify some terminology to begin with. You hear often people talk about pump jacks. What is a pump jack? Now, you probably heard me call them a unit, and that's also a short word. Referring to one of these as a pump jack is really incorrect. I know that that's kind of become the industry name for them now, but that's not actually the real name. A pump jack, or a jack, is a type of unit or a type of structure, whatever you have, that runs off a rod line in a powerhouse. And I'd like to take and show you one. I've got a video on my phone. I'm actually not going to drive, it's a pretty good ways away, but I've got a video I want to show you an actual jack. Now this jack is called a direct lift jack, often called an Oklahoma pattern jack or a Tulsa pattern jack, because they were mostly made in Oklahoma, or in Tulsa actually. And anyway, they made these in a lot of knockoff copies and stuff, but they mostly all look like this. An underpull is another kind of jack. Now, what we're working on today is actually a pumping unit, and I refer to them as a unit in short. But a pumping unit, as the name implies, was an entire unit that could pump a well. It was the only thing it needed was an electric motor or a gas engine on it, and so the terminology is not really correct to call it a pump jack, even though that's what everybody does. But I wanted to clarify that what I'm calling a unit is what most people call a pump jack. It's just a name, but that's actually where the names come from. A pump jack was actually different from a pumping unit, especially in the old days. So the very first thing we need to talk about is the size. What do the sizes mean? Now this is a 25D. Now what this means is that the gearbox output is rated at 25,000 inch-pounds of torque. If there is a plate back here, it would tell us peak torque rating in thousands of inch-pounds, 25,000 inch-pounds. Let's go look at a few others. So this is a size 57. I left it running, we can listen to it. This will kind of give you an idea of the size. It's quite a bit bigger than a 25. All right, here we go again. Here's a bigger unit. This is actually a Continental IMSCO National Hybrid. Somebody's put a National gearbox on a Continental IMSCO frame. This is a 228 frame. You can see it's quite a bit bigger. The head up there is about 6 feet probably. If it's on the ground, it's about as tall as I am. It is, like I say, it's a 228 Continental IMSCO structure. It's got a National 160 gearbox. If this is done correctly, there's nothing wrong with it, and it was done correctly. I'm actually not even sure where the National part ends and the IMSCO part starts. So back at this well, let's look around at the bearings and see what kind of shape we think this thing might be in. We'll start off with the gearbox here. The gearbox looks pretty clean. There's a little bit of grease down here. This doesn't look terrible, and it looks relatively dry. It's not wet. You can think that the loss of oil in this thing in a year is probably pretty low, and they are all going to leak a little bit, or most of them for the most part. Looking at the bearings, there's not a lot that we can tell here. Everything is greasy. Of course, if I pump it, everything's going to be well greased. And this is a good sign. You want grease. You certainly don't want it to be dry. You don't want to see any powder. This is not a great one to be able to look at. We don't see any excessive wear. It doesn't look like the housings are into the shaft. This is kind of a rigged up bearing anyway that I've done. Nothing looks too out of whack here. We're going to say that this thing is probably a pretty good unit. Now we'll want to check on these. You'll always have, well, it doesn't have much. You'll have The shiv will move in and out, but you shouldn't have any vertical movement. The stroke length, we'll come back to this one here. This has only got two options. You can either take the tail bearing and put it in these holes or these holes. Obviously, the farther you move it back, the less stroke it'll have. It's as far forward as possible to give us a maximum stroke. So another important thing you need to look at is you need to take the top off the gearbox. All of these gearboxes have got some kind of a window you can look in, or if it's a smaller one, sometimes the whole top comes off like an American, but there'll be a way that you can see in the gearbox relatively easily. You need to look at the gears. So these don't look that bad, though they don't look that great. If you look down here at the high-speed gear, this is always the first one to go out because it spins the most. If you look at the top of the gear, you'll see that there's still a flat spot. Now that's an indication that it's okay. If the gear is sharp, that's usually not a good sign. It usually means they've been run out of oil, or they're just extremely high hour. Looking at this gear, you know, it's definitely got probably a decade left or more, or a couple of decades, but it's, you know, probably more than 50% used up. But you need to look inside the gear cases and make sure that there's not something crashed, not teeth missing, etc. I'm not going to pull the top off the other gearboxes, but I wanted to at least show you one. I would rate this at a Class A unit. I think that this is in great shape. It's there's absolutely nothing wrong with it. This is an American brand. This will actually be the brand we'll be rebuilding. We look over here. It's got a little oil here. It's kind of wet. You can see some oil running down from the gearbox here. This is not terrible. Over here, this is really greasy, but it doesn't look wet at all. It's a pretty good indication that this does not leak very much at all. We can hear the wrist pins. You can feel the wrist pins. There's no grinding. There's no sound. You can't feel any slack in anything. Looking up at the tail bearing, it's nice and greasy. There's nothing squealing. No powder. There's nothing looks bad. The same with the saddle bearing. It's been well greased. Looking at the amount of oil this thing leaks, I'd like to give you an idea. This thing takes probably, I would say, about a gallon of oil twice a year. It does not leak that much oil. I grease it every month and check the oil just about every month, and it takes quite a few grease cycles before it ever needs any oil. It would definitely go a whole year without adding oil without being a problem. Now, to change the stroke on this, the wrist pins have got 3 different holes. Now, I don't know if we can see here. See if I can keep them getting wound up in this thing. There's a 22. It'd have a 22-inch stroke here, a bigger stroke there. I can't read the number, but anyway, to change the strokes, we change which hole the wrist pin goes in. Obviously, this would be shorter. I have not put any oil in this in more than a year, and it's still actually above the full mark. Probably started a little bit over full a year or so ago. I just pulled up here. We had a rainstorm, like I say, last night. It's burnt the belts off of it. I'm gonna go over there and turn the motor off and bring some belts to put on it tomorrow. But there we go again. I'm hoping this one will run. Everything's nice and greasy. You know, you can look in here, you can tell there's no gap that you can see like something's worn out. I know the wind's blowing right in this mic. There's just nothing I can do about it. I'm not going to crawl up there, but all the bearings look good because I grease it every month. Everything's nice and greasy and is in good shape. Here we go again. The way you change the stroke on this is in these is to move the wrist pin into these 3 different holes. Here again, we've got a 57 Parkersburg. These are good units. I like Parkersburg. We look it over, no squeaking, no popping, no unusual noises. It looks like these don't really have tail bearings. They sort of got 2 wrist pins. But these all look rebuilt, and they are. The gearbox is clean as a whistle. This is a great unit. Skid's in good shape. Something I didn't speak about earlier, I forgot. You need to look the skid over and make sure the skid's in good shape, because if the skid's rotted, you may have to put another skid under it. We got back over there. I don't know if you can pick it out. That is a Cabot, I believe, 57 Cabot. Okay, so here we've got a 40 Whitaker, and I'd like to show you a few problems. This is actually down for repairs, and it's waiting on me to have a few days to work on it. So if we look at the saddle bearing here, if you look up in here, you can see a gap. You can see that there's bearing wear, and the bearing material is worn, and the shaft is worn, so that it has set down inside these caps. It may not be super easy to see on the video, but there's a significant gap here, almost big enough to put my finger in. This bearing is completely shot. You can see there's a gap right here, and this bearing was going kerwham, kerwham. It was making all this racket. And though this isn't a big problem, this is something that's got to be fixed. This is actually the reason that I shut this thing down, not this bearing. I would have run it for another month or so until I got to it. But this was just about to crater, and if one of those bolts breaks, which it's slamming like it was doing, causes metal fatigue and will break the bolts, you run the possibility of just absolutely cratering this thing. I'm not a big fan of these Whitakers. You can see the wrist pins here are actually just pillow block bearings. They're not spherical rollers. We'll kind of show that more when we rebuild it. I mean, these are okay, but they're definitely not my favorite. Let's take a look at this little piece of junk. So this is probably a 40, I'm guessing. An IDECO. It stands for International Boiler something Engineers and Company. I don't remember. Let's see if it's got a nameplate on it. I'm kind of curious now. IDECO, International Derrick and Equipment Company. I knew it was something like that. Anyway, I'm not a big fan of these IDECOs, but let's look this thing over. We can see quite a bit of movement here in the saddle bearing. The saddle bearing's not super awesome. You can see it sort of spread apart right here when it pounds fluid. I don't know how well you can see that. The tail bearing looks all right. It's kind of moving left and right and banging, but I think that that's because of the skid we'll get to in a minute. It actually looks really good to me. Wrist pins look pretty good. They're nice and greasy, but the skid's coming apart. You notice that's why it's got a chain and boomer that's got the gearbox held down. Of course, that's temporary, but nonetheless. So if we look right here, you can see that there's a shim for some reason. I guess somebody was trying to patch it together, but this is all broke. Now this is not a big repair. You're saying, well, it just needs welded up. Well, you're correct, but it's going to take a winch truck to come out here, pull the gearbox off of it, and then hire a welder to come out here and lay a piece of 1/2-inch flat strap bar across that to the back of the gearbox, weld it all out and blow some holes in it. It's going to cost $2 grand. Not a big deal, but it's something that needs to be considered. Like Mitch's cows think I might be the guy to feed them today. So let's look at a piece of junk. I bet this is probably a 25, might be a 40. A little Cabot. This thing's obviously leaking really bad. The gearbox needs to be disassembled and rebuilt. As far as the wrist pins go, I don't know how well you can see, but they're jarring and moving in and out. It's kind of hard to show. It's got some kind of a homemade, I don't think that this is factory tail bearing-ish thing. It's rattling and banging. It's been popping. I don't actually hear it now, but it's been making a clicking noise. The saddle bearing doesn't look that great. It's probably all right. Anyway, this needs a total rebuild. All right, so there's one more aspect to talk about, and that is double reduction versus a single reduction gearbox. Now, everything we've looked at so far has been a double reduction gearbox, or most people don't call it that. It's just what is normal. It's got a normal gearbox. And what that is it's actually got 4 gears in it with an intermediate set, so that you've got 2 different step downs of speed. And most of these gearboxes will be from 25-ish to 32 or 3-to-1 ratio, meaning the shiv turns 30 revolutions per every stroke. Now there are single reduction gearboxes, and they use a much lower gear ratio, much numerically lower, a much higher ratio, because there's only 2 gears. You've only got the bull gear, and then you've got one small gear that's a high-speed gear that runs on it. Most of those are always a 10-to-1 ratio. I don't know why they're exactly 10-to-1. But anyway, let's run over here and look at one. It's actually the one I've shown y'all several times. All right, so here is I think this was it's maybe a 228, either 228 or a 160 antique, freaking old American. Now what I wanted to talk about is the gearbox style. Now this is a single reduction. You've only got one gear in here, and it turns one big bull gear. Now if you look at the outline of the gear case, you can actually see how huge that gear in there is turning, and the high speed's relatively small. So I had to add here, I think sometimes visually the size of something gets lost in a video without a reference. So the gear that's inside this case is actually taller than the case you can see here, because the casting of the case, the gear actually sticks down below the flange. It sticks between the beam of the gearbox there. And to give a size comparison, if you'll notice, the bolts or the nuts that actually hold the gearbox together are about as big around as that Gatorade bottle is down there. Maybe not quite that big. Anyway, the gearbox here is about 5 or 6 feet from the flange to the top of it. And I bet that the actual gear that's in the gearbox is at least 6 feet, if not 7 or 8 feet in diameter. It's quite large. Like I say, the gear ratio on these are 10-to-1. Now to keep these from going way too fast, you've got to run jack shaft. Now jack shaft is not a problem, other than it's 2 more seals to leak. It's 1 more thing to put oil in. It's 1 more thing to have problems with, and it's several more belts. Now I've got 6 belts running instead of just, you know, maybe 2. Now this shiv wobbles, I know it. It's just not on right, and it's been that way for years. I don't think it's a problem. But one other problem is since this is numerically such a lower ratio, it takes a lot more force to turn the shiv, and so you've got a much higher belt load. And you can see all the belt powder that's collected right there from these belts slipping. I go through a set of belts on this probably about 4 or 5 times a year, as compared to that other well that had the belt squaring off of it today. Has probably been more than 1 year since I put belts on it. One of the really good things about these old antique units is how they're just so overbuilt. You know, they're a little bit problematic with the rest of this junk you got to deal with, jack shafts and all, but they're so over designed that you never ever have problem with them. You know, it's got a big huge beam arms. The equalizer beam up there is huge. All the bearings are massive. You know, the shaft coming into the saddle bearing is probably 8-inch shaft or bigger. You know, everything's just huge. You know, the structure is, you know, what is that? At least 4-inch angle iron, 4 by 3/8 or so angle iron. Anyway, you know, they're kind of weird and problematic, but that's one good thing about them, is they are, you know, they're really heavy duty. So the next logical question is why are some units bigger than others? Why would you need a bigger unit? And a lot of people say, well, a bigger unit goes on a deeper well, and that's kind of true, but there's more logic to it than that. So for a bigger unit, you would put a bigger unit for one of 2 reasons, or for 2 reasons. And that is what the polish rod load is, how hard it is to pick up the polish rods in the pump. If everything is bigger, if it's got bigger rods and a bigger pump and more load, it's harder to pick up. You need a larger, heavier duty structure. The other reason is for stroke. So if you've got a well that makes a little bit more fluid than you can pump down, say with a 25, you might go to a 40 because it's got a longer stroke, and you can run it less strokes per minute, and everything is less stressed out. Another thing to consider is stroke length. Stroke length is not always necessarily correlated with the size of the unit. Now, generally, when a unit gets bigger, the stroke gets longer, but this isn't always true, and they're certainly not the same from one manufacturer to another. Say, for instance, like a 25 Bethlehem, I've got little short strokes. They are 24-inch stroke and a long stroke hole. A 25 Jensen has got a 36-inch stroke. Anyway, that's about the size of it. I wanted to kind of show you some of these. The American that we're going to rebuild is absolutely a worst case scenario. It's total junk. It needs a saddle bearing, wrist pins, tail bearing, high-speed bearings, high-speed gear, needs a gearbox resealed. The skid may need some work. But I want to kind of go through, I wanted to use this as an example of a kind of a DIY versus like, you know, what it costs someone just to come have someone work on it. I guess that's about the size of it. Appreciate you watching. The rest of the videos will be in the links, there'll be links in the description once they're up. Obviously I can't put them there before the videos exist, but if you're watching this at a later date, you can run down there and click on it. But anyway, appreciate you watching. Like, share, subscribe, and catch you on the next one.